Okay, so section 10.2 is about, again, we're dealing with the making inference. We're looking at the inference on mu1 minus mu2, okay? And this section is about the normal distribution. So we assume that this difference follows a normal distribution with given parameters. So we're dealing with the normal distribution. So one thing that we have to note, okay, is that the test statistic, and we're going to call this in this section z x1 x2 divided by the square root of this whole thing. Okay, so keep this in mind. Okay, so in this case, the standard deviations sigma 1 and sigma 2 are given. Okay, so if you're given that, given these two, then I can plug in these two numbers and compute the test statistics. So it makes our makes the problem a lot easier because I deal with the normal distribution, the standard normal distribution. So therefore, this makes a lot easy to come up with the decision. Okay, well, let's look at this example, two examples. So we're looking at these mean. Okay, so we're looking at the mean number of RPMs in two engines, and the question is, do the data indicate engine 2 has higher RPM than engine 1? Okay, so this is 1 and 2. So H naught, so HA would say is mu 1 less than mu 2, right? Or think about it different. The other way is mu 2 greater than mu 1? That's exactly what I want, right? Okay, so this means is that mu1 is equal to mu2. Okay, so you can just always use equal sign in the null hypothesis. Okay, so now let's compute the test statistic. Okay, so z so what I have is 1500 minus 1600. Okay, and then standard deviation is 50 square over, and how many from each here? Hmm, 30, yes, both 30. Okay, plus 60. Okay, and let me compute this. Let me see what the value is. So this is about negative 7.01. Okay, and what I'm looking at is the standard normal, and this is 0, and negative 7.01 is going to be somewhere far left. Okay, so when you look at this area to the left, the reason why this is to the left is because I have less than. Okay, so this is a left tail. Okay, so I'm looking at the left tail. Okay, but when you look this up, well, this is going to be essentially 0 because the highest value that you will have is, I think this is like negative 3.499 or something. Okay, so when you look at the when you look at a more negative number, then that's going to be even closer to 0. Okay, so the p-value is approximately 0. Okay, so therefore we reject the null. Okay. Let's look at one more. Okay. Okay, so in this case, we're looking at the same problem, but then we're assuming that these are basically the known standard deviation. So what that means is that we're looking at the same problem as before, okay, in the previous problem. So we're assuming that x1 bar, okay, so I'm looking at this Democrat. So Democrat 1 was, let's see, what was the value here? Okay, 61.704 standard deviation. So what if I assume that these are the population standard deviations? That's basically what I'm looking at here. And N1 is equal to third. Yeah, 30, yes. Okay, and X2 is equal to 61.675. Sigma 2 is 10.17, and 2 and 30 again. Okay, so that's what I'm given here, Democrat and Republican. Okay, so again, I'm testing mu1 greater than mu2. So therefore, this is simply equal sign. So in this case, I'm gonna use z. Okay, so here I have 61.704 minus 61.675 over square root of 9.55 over 30, 10.17 over 30. So let me see what this value is here. So this is approximately 0.0114. Okay, but note that this is upper tail, right? Or right tail. Okay, so what I'm looking at is I'm looking at this normal distribution and 0.0114, looking at this much area. Okay, from this I can say that this is not significant. So I do not reject the null hypothesis. Okay, so the Z table here, okay, so this was 0.01. So let me see, what was the value again? Yeah. 0.011. So therefore, this exact value here, okay, is going to be what? The closest one is that. Okay, so what that means is that the area 0.11, this much area here is going to be 1 minus 5438. Okay, that's going to be 0.4562. Okay, so my p-value 45. Let me see this again. 4562. Yes. Okay. 62. Okay, so that's my approximate p-value. Okay, so that's my approximate p-value. So therefore, I do not reject the null. Okay. I mean, same decision as the previous one. Okay, now assuming that these are actually population standard deviations, so I get the same conclusion, same decision as well.